In this episode, we will talk about nuclear threat, the physics behind the atomic bomb. Let's enjoy it. From time to time, there is always some general concern about the possible use of nuclear weapons. What if some government takes the wrong decisions? Or what if accidentally some nuclear weapon is activated? In the history, only Hiroshima and Nagasaki suffered a nuclear attack. This happened during the Second World War. But what is the physics behind a nuclear weapon? How can some materials transform a small amount of mass into a huge amount of energy? The response to this question is inside Einstein's famous equation, which shows the equivalence mass energy. Energy is equal to mass multiplied by the square of the speed of light. This means that a small amount of mass can be transformed into a huge amount of energy, and vice versa. A huge amount of energy can be converted into mass. This equation emerged naturally from special relativity when space and time are taken on an equal footing. The space-time then takes the energy and momentum as equivalent into a single mathematical object called quadrivector. The energy is the temporal component of this quadrivector, and the momentum is the spatial component of the same vector. The equivalence mass energy is fundamental in gravity. The source of gravity in Einstein equations is the energy momentum tensor, which contains as components the energy density, the pressure densities, the momentum, and the energy flux of a system. Then Einstein gravity also takes energy and mass on an equal footing. One interesting consequence of the equivalence mass energy is the nuclear fission. In this mechanism, certain radioactive material spontaneously decays, dividing itself into smaller pieces. The sum of the masses of the smaller pieces is inferior to the original total mass of the radioactive material. The radioactive material is normally taken as uranium. In the case of fission, the mixed mass transforms into kinetic energy. The process then repeats multiple times and it becomes a chain reaction. This chain reaction can be controlled as it occurs in nuclear plants or uncontrolled as it occurs in nuclear weapons. The controlled chain reaction of uranium is used for generating electricity in nuclear plants. The mass is transformed in kinetic energy of the decaying mass, and this kinetic energy subsequently moves the engines to generate electricity. The controlled chain reactions occurs when the mass of the radioactive material is inferior to a critical mass. The critical mass marks the minimal value necessary for having an uncontrolled chain reaction or explosion. Uncontrolled chain reactions, on the other hand, occurs when the radioactive mass stored in some place overpasses the critical mass. When this occurs, the chain reaction cannot be stopped and an inevitable explosion will come. The atomic bombs will usually contain radioactive material with 4 or 5 times the critical mass, generating in this way a very powerful explosion. The hydrogen bomb is another prototype of nuclear arsenal. It is by far more powerful than the atomic bomb based purely on fission. This type of bomb uses fission as ignition with a subsequent process of fusion. Fusion is a mechanism which releases more energy than fission, and it consists of the union of two atomic nucleus. Usually the hydrogen bomb is based on deuterium and tritium for the fusion process and uranium or plutonium for the prior ignition process. During the process of fusion, when two nucleus join, the mass of the final product is lower than the mass of the initial pair of nucleus separated. Then, due to the equivalence mass energy, a huge amount of energy is released. Although the mechanism of fusion is so powerful, it requires an initial ignition mechanism based on fission. The reason for this is that we have not yet discovered the cold fusion. If cold fusion were discovered, we could get unlimited resources of energy. In summary, the physics of the nuclear weapons in general is based fundamentally on natural consequences of special relativity. If you liked this video, please give us a like, share the link, and subscribe to the channel. More videos in Spanish and in English are coming very soon. Continue with us.